Good morning. I think it is morning, isn't it? Kinda? That's good. There's a full room. I like it. All right. So, question first. How would you like to do the same work and get paid 4 times, 5 times, 6 times? Hands up? Yeah. See? Oh, there's one guy down there. Ouch. So, I'm here to talk to you about adaptive UX, and if you have heard about it, excellent. If you haven't, this may blow your mind, kind of. So, with Windows 10 now, there's a whole new paradigm, and I'll get into that shortly. But first, I want to talk about fragmentation. And I'm wondering, if you hear fragmentation, what do you think about? Like, are you thinking development, or are you thinking design, or a bit of both? No? Anyone? Hey? Slide deck. Good point. I think I have to press that button. Yes. There you go. Still the first slide. So fragmentation. Fragmentation is something that, as developers, we loathe. We may not know it, but it is a real pain to work with. To put it in context, before we get into Windows 10, anyone want to venture a guess of what this is? Yeah? Say again? No, it's close though. This is a graphical representation of the most common Android devices. The most common ones. As you can see up the top, there's your galaxies. And they are by far the most common ones, your Galaxy, but still they're not common if you look at the greater scheme of things. Like, holy moly, there's a lot of devices. And the really cool thing about all of these devices is that they currently run about 5 or 6 different operating systems. So, as you can see on the slide, I'll try. There you go. So this is now. That end thing here is now. So each of the colored bits is how much proportionally is running a given version of Android. So the latest version, 5.1, can't even see it. Like, it's such a small number at the top. And then there's some on 5, a good chunk on 4.4, and so on. And you can see this has been a problem all along. If you do any vertical line down the middle, you'll see at any point in time there's this fragmentation of Android operating systems. And the best thing is that it's open source. So every single vendor can go in and grab that code and say, I'm just going to add X, Y, and Z. And then it becomes Android 4.4. Samsung. So even though this is 5 or 6, there's possibly as many as you saw before. And then it gets even better though, because we have this thing here. And this is what my friend was saying before. These are all the different sizes of Android devices. Like, there's that outer one is a 21-inch something rather device that runs Android. So 21-inch down to 3? And there are so many here. This is from, if you go to the slide deck, there's here's the address. And you can actually hover over and you can see what the different dimensions are and which devices and all that sort of stuff. And it's mind-blowing. There are so many. In fact, there are 24,000 distinct Android devices. So we're talking different vendor, operating system, version, screen size, 24,000 of them. Now, you're a developer, go develop for all of them. Hey! It's mad. And even if you think Samsung is by far the largest vendor of these of the Android devices, they only have 37%. There's still 60% or more that you need to cater for in terms of Android. And that gives us 1,300 brands as well, which is quite a lot. And then we go to the other side of the spectrum, and we have iOS, and you get that. So if you don't like it, tough luck. That's it. I like the Apple devices. I just find it extremely restrictive. And that's what you have. So you have your iPad mini, your iPhone 6, fat, big, XL, what it's called. iPhone 6, 5, and I think it's 4, the last one. That's it. That's the size you've got. That's excellent as a developer, because you'll just have one main aim of developing for them, but you have no wriggle room. And as a vendor, hang on, there is only Apple. Never mind. So, no, I shouldn't be too harsh. They're doing very well. But now we have Windows 10, or as I like to look at it. We have Windows 10. Whee! Who doesn't like Ninja Cat with HoloLens and band and no, anyway. And then with Windows 10, there's now, you've probably heard of it, there's like a common core API that we'll get into a bit as well. And this means that you have a common sort of language or rule, but Microsoft still had quite a difficult challenge because there's now 75 million PCs running it, which is, hey, hooray, that's pretty cool. But it's still 1,900 or 19,000 different vendors or machines, essentially. So there's still a massive challenge to get this running on all these different devices. But yet, it's still one Windows. Anyone want to venture a guess at what this is? What do all these have in common? So these are companies. They keep coming. Anyone? These are all manufacturers of Windows Phone devices. And there's actually a couple more that I didn't put on there. So even though we think, well, it's just Nokia or Microsoft Lumia devices as it is now, maybe an odd HTC in there, there are a lot of sort of low-end, entry-level budget devices in the world. And even though we think of the 640 XL or the 530 as the main devices and the low end, these are selling quite well. And I don't know what an eyeball is or a Lennox, but they exist. And then on top of this, we've got to support all of these devices. So we've got phone, phablets, tablets, laptops, desktops. We've even got that crazy Surface Hub. Have anyone played with that? That's mad, because it's a touchscreen, but it's like this big, so you go up to it and you sort of go, holy, and you sort of try and, it's very odd. But we got to make Windows work on that as well. And Xbox, it's coming. There's going to be all sorts of goodies on Xbox. Cortana, for example, which I'll talk on Friday. HoloLens, surely everybody's heard about HoloLens. Yes? And we all have one? No. Very disappointing. And then the solution to all this is to build universal apps. And as a developer, this is really a cool thing, and it's really easy. And I think Microsoft probably did go through a lot of pain just to get this out the door, because if you look at the stuff that it has to run on, IoT devices and Xbox and everything, all of it has a common code base that runs, and I think it's pretty impressive. So today we're just going to talk a little bit about adaptive user interfaces, because there's so much content here that it's just, we could be here all day. I'll drink. So why am I up here? Why am I talking to you guys? So I'm MVP within the Windows development platform. And I think there's a couple more of these guys in here as well, or at least at the event. I am, if you haven't guessed it, I'm from the western island of New Zealand. I am Danish, so I'm allowed to make jokes about the Australians, and I think you'll appreciate it. This was the I like this. I never knew New Zealand was that big. And then I have a blog where I try and write about this stuff and other stuff, and I have many, many interests, because otherwise I would go insane. I write some Pluralsight courses on this topic, as well as done KITS courses. I did a security review type thing with Troy Hunt. I organise the DDD Melbourne conference, which is yearly, about 350 people. And I don't know, do you have DDD in New Zealand? Yes, you do. Whereabouts? DDD, as in developer. It's a conference concept. Now, if anyone wants to try and organise one of these, come and talk to me, because we have done it for 6 years now, and it's a community conference, and it's to foster new speakers. It's to give new speakers a chance, as well as experienced speakers. So you submit a proposal, and the community vote for it. And it's actually really, really cool, and it gets you networking with lots of people. I have a podcast, which I encourage you to listen to. There's a lot of rambling, which is kind of funny. And the latest episode just went out a couple of days ago about Windows 10. And then we have this segment of things we know nothing about, which really, really goes wrong often, because we don't know anything. And then just to top it off, I run a B&B. So I don't just do software development as a consultant, even though I do a lot of that. But I also run that B&B there as well, in Victoria, in Australia, the West Island. All right, enough. So, adaptive interfaces. I like to call this, as you can see, bringing sanity back, because have anyone here developed for Android? Has anyone actually ventured into it either through Xamarin or native Android? Yeah, there's a couple. And do you sit and rock in a corner sometimes? Yeah. It is a bit like that, and it's a pity because Android has a lot to offer. It's just, it's so hard. Like, you have now, there has to be services now that offer testing on thousands of devices. So you upload your APK file, I think it is, or package, and it gets deployed to hundreds of devices and you pay through the nose. But that's the only way that you can test on the majority of the common devices. And it is insanity. It's just mad that you have to do this even if you're a single, independent developer, how the hell you can do that? You don't have thousands of dollars of budget to do testing on those. And then you can go the other way and you can do it with iOS, which is very sane, but you can't do anything. You can't even have a Windows 10 PC to run the IDE on. So I like to call this bringing sanity back. I want to start just with, this has confused many, me included. There's probably you've heard of Universal Apps from Windows 8 and Windows Phone 8 days. That's not the same as Universal Apps for Windows 10. They're similar, but they're different things. And this will confuse people for a long time to come. So we have on one side we have Windows 8.1, as it is, and then we have Windows 10. The easiest way to look at it is that Windows 8.1 only runs in full screen. So you remember the whole RT apps, you ran them and it takes over the screen and everything, and they improved it a little bit with 8.1. Windows 10, you can resize them and they can run in a window just on their own, like anything else. You used to have to use PCLs, portable class libraries, so that was your common code, usually your business logic, and that would be distributed with each target device. So if you're doing phone and desktop, which was the most common ones, you would have a PCL that would get pushed out to both. Now you have XAML as well as PCL. So the XAML is, part of it is the adaptive UI, and you now have a single package rather than having to have multiple XAMLs. It was just the WinRT. Now we have the core API and WinRT. So the API has been improved, and you've got this core API layer that is a contract between the developer, you guys, and Microsoft saying, no, we're going to promise you that if you develop for the core API, it will always run on every single Windows 10 device. So that's the promise they've made. And then we have one binary, which I think is pretty important now. One binary per target. Now, Joe, yesterday, if you were at the keynote, spoke a little bit about this. So it's one binary that runs on the phone, on the Xbox, on the HoloLens, on the desktop. Where it used to be, you had to compile one for each and push out. Here's your phone DLL or your phone package, and here's your desktop package, and so on. And then the really important thing to me is that we used to compile to IL, in intermediate language, and now we can compile to .NET Native. And that might sound like a little bit of an aside, but just to emphasize it, I just want to go into what that means. So, .NET Native, it's a pre-compilation of your code, and it bypasses the IL pretty much. And as it says there, it targets both .NET and Windows 10 and turns it into native code. What this means that your apps are going to be a hell of a lot faster, both in startup from cold and hot states. You can continue to program in C# or VB. There's no difference whatsoever in how you develop in the language in Visual Studio. And it still has garbage collection and exception handling and all the good stuff that we normally get from managed code as well. So that means that you used to have .NET go into IL, and then that would then go into native code. So you had this layer, step in between, which is what the device was doing. This is now completely bypassed. So just a bit of a catch-up, a gotcha, I guess, is that if you are running in debug mode in Visual Studio, it will still compile to IL, just because otherwise it doesn't have all the symbols and everything. But if you do release mode, it'll compile directly to native code. So as developers, this means you get really, really good performance. It doesn't mean you don't have to worry about performance. I had a conversation yesterday with someone saying that, oh, but performance, you get that for free, don't you? No, not quite. It's better. This isn't web, thank God. But it's still, you got to care about performance in how you handle your memory and in your collections and so on. You still use C#, as I said before. This is a big thing. Is anyone here not using C#? Or doesn't want to admit it? VB? Java, okay. Oh, see, we should embrace this man. See, very brave. Thank you for coming. And you can still use all of the .NET goodness that you're used to. Sorry, And then for users, because they don't really care, to be honest, what you compiled it in or how you wrote your code, it just means that it's fast. It is really fast. I don't know if you've noticed it, or if you have a Windows 10 mobile device, even though they don't exist, but you can install it on your current Windows phone. And apps just start a lot quicker. It's a lot smoother if they're written for .NET native code. It's low cost, as in the memory management and everything like that is, it's much smaller memory footprint is what I was trying to say. And it's optimized, so you get the best performance every time. You don't have this layer where you sort of hope that the ILA intermediate language is interpreted correctly. So that's the .NET Native, and I encourage you to go and read more about it because it is quite revolutionary in the way that it affects you as developers. Even though you don't have to think much about it when you develop, it's really good to know what it does and why it does it. Next, we'll have a look at this. It's called scaling algorithm. So the problem is, I'll try and see if I can visualize it. So if you have a phone and you run the same app on this phone as you do on the screen, if you look at something here, that looks about the same as if you look at that there, because the distance you have to the screen does that your relative perspective of what you're seeing is scaled. But that means that you want to have bigger things on a bigger screen. So you want your pixels to be bigger, effectively, right? And that's what this is trying to illustrate here. So what this is saying is that generally, if you're looking at a small device, you're about 16 inches. So this is a slide I generously borrowed from Microsoft. And if you're on a tablet, you're about 20. On a desktop, 28 inches, and so on. So your distance from the screen is important because that means how far away are you and how small does something look on the screen. And what Microsoft's trying to do is normalize the way that controls and fonts and everything else reacts to this, so that when you put a date picker control on your screen, it doesn't matter if you're targeting phone or the Surface Hub for that matter, even though that's a bit of a special case, or desktop, let's say. So it takes into account viewing distance and screen density, so pixels per inch, and it optimizes the perceived size of things. And they won't tell you exactly what this algorithm is, of course, but does that make sense? Because this is pretty important, that there is a scaling algorithm which does all the hard work for you guys. And this then comes back into what's called effective pixels. So we're not designing or we're not programming or coding in real pixels. We're coding in effective pixels. And that means that, as I said before, if you have 3 dots or 3 squares here, they will appear the same size to the user because they're different distances, but effectively they're different sizes, right? But when you put it on the screen, you just said, no, it's 80 by 80. And then you don't worry about it. And then it's the scaling algorithm that knows the device it's running on, and then it scales up the pixels to what the right resolution is for that particular screen. And generally, you'll say that you have 320 pixels for a phone. So these are effective pixels again. We're not talking about a phone that's high def. In general, you have 320 pixels when you're developing and designing. You get 720 for a phablet or a tablet, and a desktop has about 1024. So that's really simple. It doesn't always work exactly like that, but generally that's pretty much how it is. So something that appears as 1 inch or 1 centimeter by 1 centimeter on a large screen will also appear as 1 centimeter by 1 centimeter on a phone. And that's important too, because that again means that you don't have to worry about all these screen sizes when you're developing. So you're not an Android developer, right? You're not being put in this thing of going, oh, go find out. All right. So let's see if we can build some of this stuff, or at least look at what it would look like. The next slide is a bit of a no-brainer, but if you don't know where to get the tools, it's Visual Studio. It's at visualstudio.microsoft.com or visualstudio.com, something like that. And there's a free community edition, so go and download it. Just bear in mind, when you install it, you tick that box that says Universal Windows Apps, because otherwise you get none of this. And if you just click next, 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 you don't get this. I don't know why this box is not mandatory, because developers normally like to look at what they're installing. So if you are going to have a look at this, and I encourage you because it's pretty cool, Visual Studio is the way to go. All right, relative panel. So this is one of the new XAML controls, which is very much aimed at this adaptive user interface. It's a layout control, and it's very much like Bootstrap for web, if anyone's a web developer. Sort of you get that sort of grid idea. It's not quite the same, but that sort of, if you get in that mindset, that sort of gives you a pretty good start on it. So if we look at some of the code here. So this is, I'll show you this live in a minute, all being well. I'm not sure. Yep. So we have, it's just XAML. Is anyone not familiar with XAML? If I say XAML, people go, oh, what? No? Okay, cool. So XAML is how you describe the elements. It's a compiled UI language, I guess. So you have a relative panel, and you just populate it with rectangles. And then what you do is you have, I'll use this again, you say relative panel align left with, and below that, it's very verbose and quite nice to work with. And when you put this in to Visual Studio, you get that. So I'll show you that very shortly in code, so you get an idea for it. All right. Now, okay, switching. Cool. So this is, I'll just minimize that and that. This is the Mail app. Joel Belfiore showed that yesterday. I just wanted to reiterate it, also because I already had it in my slide, and I was before him, so I'm not going to batch down. And this makes use of the relative panel as well as other adaptive UI features. And it is built as a universal app, so it is one code base. You can read my emails if you want. And so on the phone, it's the exact same app that runs there. It's the exact same binary, and that is important because it's less work for you guys. You write it once, and if you get your UI right, then you can deploy it to 4, 5, 6 different devices. So what this does is that as you resize it, it'll change its look and feel to be best suited to what screen it's on. So here, if we have a smaller screen, as you scroll this out, then you get the reading pane here. And then on the other side, you then suddenly your menu, which is your famous hamburger menu here, comes up as a flyout menu. But then if you kept resizing it, then suddenly you have enough room, and then it becomes a menu of it, or a pane of its own. And that's sort of the idea, is that you have these states that looks at how big the application is, and as you change it, it'll then hide, collapse, move. Some apps would take columns and put them into one column or 2 columns. There's many ways that you can adapt your user interface, but only you will know what that is, what the right way is. So that's the Mail app. Now we'll have a look at I'm doing this for my Surface Pro Original because my computer crashed. So it's pretty good though, isn't it? It's still going. So what we have here is we have, if you are familiar with this view, with XAML view, we have a preview at the top, and right now we are looking at a 5-inch phone. That's a new feature for Universal Apps as well, is that you have this target view or target designer mode, and you can choose any of these devices and see what it looks like. So we could choose, say, an 8-inch tablet, and the designer would change to show what the layout will look like then. So that's in design mode. You have this before. You don't have to compile it. You don't have to deploy it to, God knows, 24,000 Android devices. You just have it here in the designer. And obviously, we don't have all devices here, but there's a pretty good selection. That's not bad. Even have the 84-inch Surface Hub. Oh, God, what's going to happen now? Yep, there we go. Yellow box going mad. But again, you can see it's the relative pixels and the scaling algorithm is working because that looks the same size. It hasn't suddenly made it really, really tiny in the corner. So that's the idea with that. Okay, let's go back to the 8-inch tablet. So that's the code down there. And again, it's the same we saw before. And the important things is, well, it's so simple that I can't make it super exciting. Like, normally there's something, and then if you put this property in and you then bind it to no. It is just this simple. You have the red rectangle, we fill the red, and we have blue rectangle, we fill the red, and then we say, oh, it has to be the right of the red rectangle, and it will be there. Like, there's nothing else to it. So it's not terribly exciting in terms of awesome code, but it's awesome code because it's so simple. I'm one of those developers that love deleting code. I don't know if that's you as well. The more code I delete, the better day I had. So if we try and run this on the local machine, storing packages. Now, does this make sense? Feel free to ask questions. I know there's a Q&A at the end, but I'm happy to take questions if there's something right now that doesn't make sense. So please don't tell me you're a Norwegian audience. Oh, yes, thank you.
It makes a lot of sense. It's quite exciting. But I'm just wondering, this algorithm that they're using projecting, are they, you've got Xamarin, are they actually thinking of maybe incorporating them some Xamarin so that we can leverage this for when we, because obviously we're not just going to develop with mobile devices, because I'm like develop with an Android device.
Yeah.
So are we going to be able to leverage that for everything's there to, empower Xamarin?
So the question is, will the scaling algorithm also be ported, say, to Xamarin so that we can use this for Android devices? I don't know. I think that's a really good idea. I'm pretty sure that with the Project Astoria, if you've heard of that, the Universal App Bridge, which you can take your Android code and make it into a Windows Universal App, that will probably take advantage of it, I could imagine. But that's, again, targeting Windows. So targeting other platforms, I'm not sure. I don't actually know. I like it. No, you can go. That's all right.
I was going to ask another question. I mean, I guess that, Microsoft, forgive me for saying this, but obviously really missed the boat with mobile devices.
Yep.
Do you think this is going to give them that leverage so that they can capture some of that market value?
Wow, that's a let's ponder question. That's a much bigger question, to be honest. Personally, yes, but I'm also a fanboy, right? I mean, I drink the Kool-Aid, so I'd hope so, definitely. Anyway, here's our relative panel going, and we can again see it adapts, right? So we have the yellow box here that adapts. And if you want this sample, it's purely stolen from a Microsoft webinar that they did, just because I didn't want to reinvent the wheel. So if you guys want this code, you can have it, no problem at all, and play with it. And so that's the relative panel. And we can move stuff around. We could say that the yellow should be under the blue, and it will just move it up. And it's really not that exciting. But it's very powerful. It's really, really powerful. Okay. So that's the relative panel. I'm just going to switch back here. Okay. The other really, really important thing is visual states. So visual states, as it says, allows you to define different selectable layouts that can be applied to your UI. So in other words, it allows you to have a block of XAML that's dependent on a certain state of your app. And then this block of XAML does something. And Excuse me. Swallow the frog. So, as we saw before in the Mail app, that means that you can have panels that are collapsing or hiding or minimizing or changing shape entirely. And we used to do this. We could do this in Windows 8, and lots of people did it. And it was done through code. So you defined your XAML, and you had that marked with certain keywords, and you can then say, oh, when size is changed, check for the size, and I'll change the state of my app. And you did it like this: Visual State Manager.GoToState. And it is lots of magic strings, which we all love in development. And they've then changed it now, so it's much, 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 much more simple. So the visual state now is a native SAML component, and you have this called adaptive triggers. And this is another really powerful thing in terms of UI. So now, let's see if the demo gods are with me. We'll do this from scratch. All right. So I'll go up here, I'll do File, New, Find a project. And, another gotcha here. Windows section of templates. If you go into Windows 8, there's also universal. Again, those are the two different ones, right? That's not the same. You can really get caught out if you think, but I did do, no. So don't go into Windows 8. In fact, unless you have a really specific purpose or maintaining an app, don't use the Windows 8 stuff. Because the Windows 10, as far as I'm aware, will run on Windows 8 as well. So we'll create a little app here, and we'll call this state. That'll do. And then, are people here familiar with Blend? Yes, there's a lot of nodding. Hands up who really, really likes it. 2. I don't know why it's got such a bad reputation. I tend to always start in Blend. I don't know if I'm just odd, again, just drinking the Kool-Aid. Yes, it has crashed on me. Yes, it has. But it's really, really powerful. It's like a good version of Photoshop. I don't understand Photoshop, that's probably why. So what we're going to do here is take main page, once it loads, and we're going to design this in Blend. And now I'm going to dance, because this may take a while. The reason I'm doing this in Blend is that the visual states are so much easier to manage in Blend. Basically, you can do it all without any code. Whereas in Visual Studio IDE, you kind of have to massage the XAML and use tricks and stuff. So once this loads, I'll show you. This is going to be an example of brilliant UI, by the way. Yes?
With the scaling algorithm, if you now say something has a width of 100, what does that mean?
So the question is, with the scaling algorithm, if you said width as 100, what does that mean? It means that it's 100 effective pixels.
Okay, so this is effective.
It's effective pixels, yeah. And again, that means that if you then take this and project it on a big screen, it's still 100 effective pixels, but the scaling algorithm would then scale it up so it looks like it belongs.
And is the relationship then between effective pixels and the actual physical measurement? So you can say 100 effective pixels is 10 centimeters.
Okay, if you can set what effective pixels are, is that what you're saying? Can you define what they are?
Well, can we define or is
No.
it already defined?
Yeah, it's done for you, essentially. Because the way that it works is that it looks at DPI and it looks at device size, and there's a whole bunch of factors that goes into it, so I don't think they want you to mess with it, is sort of what I'm thinking. Yeah?
So there's something that actually says an effective pixel is so many inches at such and such viewing distance?
Yeah, I can't remember. So the question is there an actual measurement? So we say effective pixels is one is 100 effective pixels at such a distance is so many pixels. I believe there's, yeah. But it again depends on your screen resolution and many other things. So, all right, let's get this going. So here we're going to, first off, have a beautiful rectangle. So we have one here, and once that comes up, there we go. Make that blue, because I like blue. And then we have another rectangle. We'll put it over here. And what color? Yes. That was my interactive segment for the day. So now we got 2 boxes, right? Not terribly exciting. I did tell you it was going to be an excellent UI. So we've selected the green box, and then up here under states, so there's the Solution Explorer, your assets and your states. We want to create a new state. And we'll just call it Visual State Group, that's fine. We add the state here. Well, we added 2 apparently. And Visual State, and we'll call this, there we go, min 800. And then the little lightning bolt here is where we add an adaptive trigger. Now I won't have time to go into it today, but you can also create your own triggers, and it's really simple. So you could have an orientation trigger that would then, if the width is less than the height, it would say, oh, it's portrait, and so on. And you can do different things on your model. But you can have any kind of trigger that you'd like that goes into to this. So here, I'll just expand this so you can see. So this one, you probably guessed it, minimum width 800. And then we're going to, so there's a little red border around this, as you can see. That means it's recording. So whatever I change now will happen in that state. So I'll say that green box is going to be collapsed. And that's it. And then, save it. I want another state, and I'm going to have this as min 1. And I think I took them the wrong way now. Anyway, we add another adaptive trigger, and the minimum width is, now you have to put 1. If you put 0, it ignores you. Again, blend. So you have to put 1. And that is actually the one that's supposed to be collapsed. So I'll just do that. And then we'll go back to the other one, and we'll see that's visible. There we go. So that's the extent of my design skills. So we run this on an 8-inch tablet on the local machine. Another cool thing you can in Blend now, you can compile and run everything through Blend. Normally you had to, was a lot of swapping back and forwards. They sort of eliminated that now. Not that Blend is Visual Studio, because it certainly isn't. So while we wait for the Surface Pro Original to build this, we can take a question.
I was wondering, with the triggers, can you set like priority of what collapses first, or which?
So can you set priority on the?
The email ad.
Yeah.
And you extend it on the right side, and it shows the preview pane, and then
Oh yeah.
you extend it on the left side and show the menu. Can I choose that the menu pops up first before the preview pane?
I'm not sure. So those are different. They're separate triggers. I would have thought that they've done it with. So they have one trigger that says if the width is less than, say, 1,000, don't show this pane. And if it's less than whatever, the 320, the mobile, don't show any of them. But in terms of priority, I'm not sure, actually. I'm not sure. Oh, here we go. So if this worked, so now this moves as we thought it would. And then, wait, it disappears. Hey, isn't that amazing? And that's an adaptive trigger, just like we saw with the Mail app. And that's how simple it is. Obviously, you might want better UI than that. The green is nice, I agree. But that's really how simple it is. And it's sort of like, I was trying to think of really clever things to do with this because it's really cool. And I thought, no, it's so powerful because it's so simple. There really is not much to it. Obviously, you can do your own triggers based on different variables being whatever, and you can do a lot more custom stuff with it. And I'm happy to show someone if anyone wants to know about it. So that's your adaptive triggers for your visual states. Yeah?
So in the example that you had for Windows 8, it looked like it was the wrong way around as well. But this one too, obviously if it's in WinState min 800, it's also in WinState min 1, right? How does it know to pick?
Good, very good question. So the question is, how does the app know what trigger to trigger? Because they're both valid currently. They both should be collapsed and hidden. So it always goes, for this particular trigger, because it's minimum width, it always goes from the largest, and then when it hits one, it then says, yep, that's it. So that's a good question. Yep, good point. All right. Let's swap back to the slides. Okay. There's one last thing I just want to talk to you about as well. It's called XAML View. Because it may be that, especially when Xbox comes out, I could imagine that a lot of apps don't actually want anything to do with the same user interface as phone or as laptop, for example. But you may want to maintain the same view models and the same models and data logic and business layers and everything. And that's normally what you would do with a PCL, with a portable class library, and you would then have different UIs for everything. So there's a way now that's called XAML View, and it's a way of setting a custom XAML for a particular device. So it's family of devices. So we'll see if that will work as well. Okay. So you can see this all right, by the way? I forgot to ask about it's okay? Yeah, cool. A bit late to ask, but oh well. So the XAML view is basically a replacement of the view that you're requesting if there is a certain device family present. So I'll just show you this first. So this is, again, is an example of blatantly stolen from MSDN, or from, I can't remember, some Microsoft site, because I thought, well, if you've got to go find it, you'll look at the same thing. And what this does, it just has a text block at the top, as you can see, and there's a text block at the bottom, which is set in code. That's all it is. So if you run it, building, then it'll just show the text block at the top, and it'll have the text block at the bottom, which has been set in the code behind. Go. That's it, right? So that makes sense. Pretty simple. Again, this is all really simple stuff, because the way they've done it is really quite clever. So what we can do in here, we can add a folder. This is important. It has to be a folder under the views. And this naming is really important as well. So device family, and then in this case, we're going to do mobile. So you could also put desktop, or I can't remember what all the exact strings are, but this again is a magic string, and you then put that there. You then add a new item, excuse me, and it's a XAML view. So it's actually an item in there. And it's going to try and tell you it's really main page 1, but it has to be the same name as the view that you're trying to replace. So we're going to call it main page.xaml. And it'll create it for us. In there. And, I didn't start this up. Hang on. We can talk amongst ourselves when we start it up. So in here, I'm just going to take the XAML from over here and just copy that across. Not trying to reinvent the wheel here. Replace that grid. And we'll then in the text say mobile page. So what's going to happen now is that I should probably run it because I forgot to start the emulator on this one. If it'll run, it'll realize what device it's running on. So in this case, it's mobile. It'll then go, oh, hang on, there's a folder under my views with a different XAML, and I'll go and grab that instead. But it'll still use the same code behind. I don't know if you saw it, but there is no code behind file over here. There's no code behind file on this XAML. So it is just a replacement. So it's still using the same logic, same data binding, same view models, everything can be the same. But it's just a way of not having necessarily to deal with an adaptive UI, because it can get really frustrating if you're trying to move that from up here to down there, and suddenly it gets really complicated. Yeah, that's what I thought would happen. So, because my computer is not playing ball, does that make sense though? So you have on one side you have the adaptive UI, which is your relative panels and your visual state triggers, and you use that for the single UI that you then move around and you basically glue things together that way. Or you can use, it's running. Or you can use your XAML view to replace a full view relatively easily, I would say. So I don't know if you want to wait for this. Do you trust me? It's just going to say this is a mobile code, mobile main page. Hey? I don't know. You don't know? All right, we'll wait then. It's his fault. There you go. Doesn't work anyway. So that was me trying to run it on a Surface. Yeah. And so, just to end this talk, I hope I've given you just enough of a hint of what it does and enough ideas to what you can use it for and to go play with it. But the main things you want to take away is that it's speed. This means that because it runs on .NET Native and you have a single UI, it's really fast. And it's not just fast in that way, you also develop for more devices faster because you just have a single UI to work with. Sure, it might be a pain initially to work with, but at least it's not Android, right? And means you can capitalize on your work. You can get more return on that investment that you have to convince your boss to do a Windows 10 app or whoever it is that you have to convince. The maintenance costs for this, way less code, less messy, hopefully. Like all of this is really simple code. There shouldn't be any gotchas as such that you can't find out pretty quickly if there's the little ones that I talked about. And it gives you more time to focus on the cool stuff, essentially. And then the really important thing to me is that, no, not that, 1 billion devices. You probably heard this a few times today or yesterday, but this is a really realistic goal. They didn't just grab it out of thin air, but Windows 10 will be on 1 billion devices, and this is your gateway into it. And then, of course, there's also the other universal app bridges, which I would love to talk for an hour about, but we don't have time. So that, I hope that gives you a bit of a start into adaptive UI and why it's so cool. Now, I think we have question time. Is that right? Yes? I'll go yes. Yes, down the back.
Do you see Windows Universal as sort of becoming the application platform for everything going forward? Like, will we see Visual Studio 2015 built on Universal?
So is Universal the platform for everything? I think it is. Maybe not Visual Studio. That might be grabbing it. And there's no reason really to do it. You don't want to run that on a phone necessarily. But definitely, these app bridges that are here, that at the bottom, the reason I put them there is that you have these 4 projects, which is Project Westminster, Astoria, Islandwood, and whatever the last one is. But it means you can take these project types and it'll become a universal app. So you can take your Android or your Objective-C code and it'll become a native app. And you could do it with iOS right now. There's on GitHub, it's open source. And there's a mapping between all the iOS APIs into the Windows Universal APIs. And I don't think it'll just work, but it'll be maybe 70-80% of the work done for you if you have an app. And then it'll become a universal app, and you've got another 1 billion devices to target. Anything else? Yep.
How about Unity and HoloLens and stuff like that? What's specific there?
Well, not stuff. So what's happening with Unity and HoloLens? Is that sort of what you're asking? In terms of universal apps? Is that the... I don't know about Unity, but I do know that universal apps will run on HoloLens, unless they've changed their mind. That's all the stuff I've heard about. So I don't know how that will work with your relative panels. I don't know. But it will work. There will be a common core API that will run on HoloLens as well. Unity? Don't know. Anyone else? Oh, come on. Surely. Yes?
Scaling algorithm works on the images as well?
Does it work on?
The images?
Oh, does the scaling algorithm work on images? You mean the emulators? Or images, as in photographic images? No. And I'm glad you asked that, because that is another, it's not a gotcha, but because images are images, right? You can't, like, it's not CSI, you can't go enhance. Like, it doesn't work. It just doesn't exist, right? So what the workaround or the way to do it is that you supply that image in, I can't remember, 7 or 8 different resolutions, and they have a specific naming convention that you follow, and then it'll pick the image that fits that current resolution of the app. So yes, you can, but it's a little bit more work. Yep.
And the previous session when I was talking about building universal apps, I was talking about targeting capabilities, not actual devices or families like the XAML view they seem to do. So is that a capability as well, or is that?
The XAML views? No, they're not capabilities as such. That's just, we don't know what it's running on. So whatever it's running on, we can then specifically target if there's, yeah. I should say now, before you all leave, I have free Pluralsight passes. So if you don't know what Pluralsight is, or you want 30-day free pass, I've got a boatload of them. Come and grab one. Anyway, more questions or not? We good? All right. Thanks, guys. Appreciate it. Thanks for coming.